Welcome to lesson 3.3. In this lesson, we're going to learn our final 2 advanced rules for graphing, as well as just talk about some last little tidbits with graphing rational functions. So we're going to start off right here by talking about our first advanced rule, which is all about holes. Now, first thing you need to know about a hole. A hole is a point on a graph that doesn't exist. So usually you'll have some kind of graph like this, and then it will have a hole in it, and then the graph will keep going. So a hole is an open circle at a specific point. And a hole happens when anything cancels on top and bottom. So it happens when things cancel. If anything cancels on top and bottom, that's going to create a hole. Now, we always write our holes as coordinate points, x, comma, y. And then we go to that point, say 2, 5, 2, 5, and we graph an open circle. That's how we graph holes. So let's talk about actually finding holes. Finding holes are 2 steps. You start by taking whatever you canceled on top and bottom, and you're going to set that thing that you canceled equal to 0 and solve for x. When you take the thing you canceled, set it equal to 0 and solve for x, that's going to give you the x value of your whole point. Then you're going to take this x value, and plug into simplified equation. So take the x value we found in step 1, we're going to plug it into the simplified equation, the equation that's left after we cancel things on top and bottom, and get an answer. That is the y value for our hole. So let's go to example 1 and practice this. We're going to find example 1. Now, just like we've done in 3.1 and 3.2, we're going to start by finding our domain. That's always what we find first. And we know that to find the domain, we look at the denominator. This denominator needs to factor. And then we take the things in the denominator, say that those things cannot equal 0. So I know x cannot equal 3 and x cannot equal negative 3. So my domain is everything else. There's our domain. Now, after domain, we've usually gone on to find the x-intercepts. But now we need to get used to finding the holes next. So to find the hole, we're going to factor our whole equation and see if anything cancels on top and bottom. So this equation, we already factored it. Let's see, does anything cancel on top and bottom? Looks like I have an x plus 3 on top and an x plus 3 on bottom that cancels. So to find the hole, I'm going to take the thing that I canceled on top and bottom, set it equal to 0, and that becomes the x value of my hole. To find the y value, I'm going to plug that x value into the simplified equation, the equation that's left. So if I look right here, what's left, I have a 1 on top and an x minus 3 on bottom. That's the equation that's left. So I'm going to plug negative 3 into this equation. And that gives me negative 1/6. And that is the y value of our hole. So we come over here at negative 3, negative 1/6, and graph an open circle, and that's how we graph a hole. Now let's continue graphing this equation. Now we find x-intercepts, y-intercepts, vertical asymptotes, and end behavior. Now there's a reason we found the hole before we found the rest of this. We find the hole first because the rest of all of this should be found with our simplified equation. You should never use the original equation again. You only use the original equation for the domain and to start the hole. then the rest of all of this use the simplified equation. So if I look at this simplified equation, that's what I'm going to use now. First off, I know that x-intercepts, look at the numerator, set that numerator equal to 0. This one doesn't make any sense, so we know there are no holes or DNE. Y-intercept, I plug 0 in for x, which gives me -1/3. Write that as 0, comma, the number, and graph it as a closed circle on the y-axis. There's my y-intercept. Vertical asymptotes, look at the denominator. Set that denominator equal to 0. So I get x equals 3. So I have a vertical asymptote at 3, and this is an odd asymptote because the exponent on the factor is a 1, and that is an odd number. So I can come over here at 3, do an asymptote, say it's odd, or a little o. End behavior, look at the degree on top and bottom to know which rule to use. The degree on top of our simplified equation is 0. The degree on bottom is a 1. So this is a bottom heavy end behavior, which means we know it'll be y equals 0. So do my stars over here at 0. Now if I go to graph this, I know I have to go through the hole, and I know I have to go through the y-intercept. Now if I look left of the hole, there's nothing between here and my star, so point to my star. Here I can't keep going this way because there's an asymptote, so I've got to go up or down. Can't go up because that would make an x-intercept, and I don't have one of those, so got to go down. And this is an odd asymptote, so if I point down on one side, I've got to point up on the other side. And then nothing between that, so curve around and point to my star. And that is how you graph with holes. It's basically everything the same we've learned about in 3.1 and 3.2. We just add this step for finding the hole right there, and then use the simplified equation for everything else. So from now on, every time you graph, you should always have holes after the domain, and you should always check. If you have something that cancels on top and bottom, that's a hole. If nothing cancels on top and bottom, you say holes are DNE none, because nothing canceled on top and bottom. So that is everything to do with a hole. In the next video, we're going to talk about a very specific example that is a rational function, but doesn't actually have any vertical asymptotes. This graph looks kind of weird, and we'll do that in the next